students, welcome to Shruti Academy. So we have already discussed about the efficiency of the transformer. We have already seen the maximum efficiency. We have already seen the condition for the maximum efficiency. When is the transformer at maximum efficiency? What is its condition? So now let us discuss about the value of X, value of that fraction of the load at which the maximum efficiency is achieved, then the value of the current, the secondary load current at which the maximum efficiency is there in the transformer, and the value of KVA at maximum efficiency. So we know that in some times that the transformer, when it is running, then the maximum efficiency is achieved at the full load, but it is not actually in always. In reality, always it is not true. Sometimes there is some fraction of the load is there. At that fractional load only the maximum efficiency is achieved. So we need to find out that fraction, at what fraction of the load the maximum efficiency is achieved. So we need to find out that fractional value. Okay, so that fractional value is given by X, and we will be finding out that value at which the transformer achieves the maximum efficiency. So for that, we already know a condition of the maximum efficiency, that the copper losses should be equal to the iron losses. Copper losses are the variable losses, iron losses are the constant losses. When these two losses gets equal, then only the transformer achieves the maximum efficiency. So let us write down the condition over here. So Pi is equal to PCU, then only we get the maximum efficiency. Okay, so Pi are the constant losses. Copper losses are given by I2 square Re2. So what is Re2? Re2 is the resistance referred to the secondary side. Resistance is referred to the secondary side. So the value of X also we know is given by I2, that is the actual secondary current upon IFL, I2FL, that is the full load current. That is the full load current, secondary current at the full load. So X is given by I2 upon FL. So from here we can get the value of I2. I2 will be equal to X into I2FL. X into I2FL. Okay, so we will be putting this value of secondary current in our expression for the condition of the maximum efficiency. Okay, so the condition of maximum efficiency was copper losses equal to iron losses. Copper losses equal to iron losses. Okay, so let us put the value of secondary current. So my Pi will be equal to I2 square. So it will be X square I2 FL whole square Re2. Okay, so from here X square will be equal to Pi upon I2 FL square Re2. So these are the I square R, these are the copper losses at the full load. Copper losses at the full load. So this denotes that X square will be equal to Pi upon PCU, copper losses at the full load. Okay, copper losses at the full load. So my X, the value of the fraction at the maximum efficiency, will be given by under root of Pi upon PCU full load. Okay, so this is the value of the fraction. This is the value of the fraction load at which the maximum efficiency is achieved. So for the maximum efficiency, X should be given by square root of the ratio of the iron loss to the copper loss, and that to the copper loss is the full load loss, okay, at full load. So under root pi upon PCU gives the value of the fractional load, value of that fraction at which the transformer is working at the maximum efficiency, okay. So this is the value of X. Now let us start discussing about the value of the load current at the maximum efficiency. So when my transformer is running at the maximum efficiency, what would be the current to be passed through what would be the current passing through the resistance, through the load. So the value of the load current at the maximum efficiency. So we will be starting with the condition of the maximum efficiency, that is same, that is equal to PCU is equal to PCI, PI. PI are the iron losses, which are the constant losses. PCU are the copper losses, which are the variable losses. So we are dealing here with the maximum efficiency. So we will be writing over here I2 max. I2 at maximum efficiency whole square into RE2 equal to PI Okay. So from here I2 max efficiency will be equal to, at maximum efficiency will be equal to Pi upon RE2. Pi upon RE2. RE2 is the resistance referred to the secondary side. Okay. So we will be multiplying both numerator and denominator with the secondary full load current in order to get our expression. So I2 FL upon I2 FL. So we will be multiplying both numerator and denominator with the secondary full load current. Okay, with the square of the secondary full load current. We will be multiplying both numerator and denominator with the square of the secondary full load current. Okay, so from here we can clearly see that we have got over here the copper losses at the full load I square FL RE2. These are the copper losses in the full load. We have replaced over here also I2 FL square RE2 is equals to PCU FL. So we have got I2 square FL RE2 to be equal to PCU FL. This thing can be replaced by PCU at the full load. That means the copper losses at the full load. So let us replace it. So I2 at maximum efficiency square will be equal to Pi into I2 at full load whole square upon PCU at full load. That means the iron losses upon the copper losses into the full load current square. So in order to find out the current at the maximum efficiency, we should take the square root both sides. So taking square root both sides, so here we'll be getting I2 maximum efficiency at maximum efficiency to be equal to under root Pi upon PCU into I2FL whole square. Okay, so this will come out from the under root part, but the losses, the ratio of the losses will remain in the under root only. Okay, so from here it will be, we will be getting over here I2 at maximum efficiency will be equal to I2FL under root of PI upon PCU. Okay, so PI upon PCU at full load can also be replaced by X. So this is the value of our maximum efficiency, the load current, value of the load current at the maximum efficiency. So this is the value of the load current at maximum efficiency. It is given by the multiplication of the load current at the full load into the square root of the ratio of the losses, the iron losses and the copper losses at the full load. And we also know that under root PI upon PCU is given by X. So in general we can write down I2 at maximum efficiency is equal to X into I2FL also. So in general we can also write down I2 at maximum efficiency is equals to X into I2FL, because the value of X is under root PI upon PCUFL. Okay, so now let us start discussing the value of KVA at the maximum efficiency. So we will be taking this formula itself. We know that PCU is equal to PI, because at the maximum efficiency both the losses are equal. So we will be taking this value which we derived in the this section. So I2 at maximum efficiency is given by I2FL under root PI upon PCU at full load. Okay, so we will multiplying both sides by a secondary voltage which is V2 in order to get KVA. So multiplying both sides by V2. Okay, multiplying both sides by V2. So here we get V2 I2 at maximum efficiency is equal to V2 I2 FL into under root PI upon PCU FL. Okay, so V2I2, it's KVA rating. V2I2 is given by KVA. VA, it is VA, and if we give the VA rating in kilowatts or kilo, then it is KVA. Okay, so it will be KVA at maximum efficiency to be equal to, this will be KVA at full load, into under root of PI upon PCU FL. PCU is the copper losses at the full load. Okay, are the copper losses at the full load. So this becomes a formula for the KVA rating. So in general we can give KVA at maximum efficiency is given by X into KVA ratings. because under root pi upon PCU is the value of the x at maximum efficiency. So we can replace it with x. So x into KVA ratings at the full load. So this becomes another formula, another general formula. So these formulas are useful from the numericals point of view. From the numericals point of view, they are very much useful, and they have to be kept in mind, because when the numerical comes that to find the value of the load fraction and the fractional load value and the maximum efficiency and the losses are given, so we can directly put the values over here and find out our value. We can directly take the ratio and take the square root and find the value. Similarly, with the case with the load current at the maximum efficiency, we can find out the value, and similar is the case with the KVA, we can find out the value. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.